Okay, so let's look at a couple of simple examples first, and we'll move into something a little more complicated. So if I have something simple like 5x over 16 plus 3x over 16. Notice the denominators are the same. I simply add the numerators. 5x plus 3x over 16 is 8x over 16. Now, in the end, we always want to simplify, so 8 and 16 both have a common factor of 8. I could divide both of these by 8, and I get 1 and 2, my final answer being x over 2. I could have something a little more complicated. So in that case, my denominators were very clearly the same, but it could be the case that my denominators are similar but slightly different. So for example, if I had 2 over x minus 4, and to this I'm going to add 7 over 4 minus x. Here's where our factoring comes in. When we factor before, we recognize that these two denominators are opposites, right? When I have something minus something else and then I just flip them, those are opposites. And if we remember correct from chapter 5, to make an opposite into its opposite, we kind of take the negative of it. So in other words, x minus 4 is equal to kind of the negative of 4 minus x. Or in other words, if I rewrite this the opposite of x minus 4. Now my denominators are related. I can see that they're the same if I move this negative up to the top. Remember, if I have a fraction negative a over b, I can write that as negative a over b or a over negative b. So in this case, my negative b, I can write that subtraction up there. So I get 2 over x minus 4 plus a negative 7 over x minus 4. My denominators are the same, so I write it over one denominator with the numerator. 2 minus 7 over x minus 4 is equal to negative 5 over x minus 4. Okay, one more example. What if my denominators are not the same? What if there's some significant difference? I need to find, like we did yesterday, that least common denominator. Okay, so here I have a over 4 minus 5 plus 12a over 18. So I need to find a common denominator between the 4 and the 18. So go ahead and do that. Hopefully, this isn't too complicated. All right, so our common denominator is going to be, anyone? Just kidding. 36, right? I can think about, to get to 36 would be 4 times 9 is 36. 18 times 2 is 36. Okay, so if I want to change this to fraction over 36, if I multiply the denominator by 4, I have to do the same to the numerator. So this becomes 9a over 36 minus, here I need to multiply by 2, but remember it's the whole numerator. Whole numerator. So 10 plus 24a over 36. Multiply every term by that 2. Denominators are the same, so I can add them. 9a. Now be careful. When I subtract here, I'm subtracting this whole numerator. So I'm subtracting the 10, but I'm also subtracting the 24a over 36. Now, you might be tempted to start canceling, let's say the 10 and 36. Remember, the numerator has subtraction in it, but I can't reduce when I have that subtraction there. All right, so I have a like term, though I do have a positive 9 and a negative 24. So that's going to be minus 15a minus 10 over 36. Okay, am I done? All right, hopefully we recognize that I do have a little bit more factoring I could do, right? If I wanted to, I wouldn't have to, but if I wanted to, I could factor out a 5 in the numerator here. You don't have to, but if you wanted to. The only reason that I would really want to do that is if I had, let's say, a 5 in the denominator that I could cancel. But if you wanted to, you could factor out a negative 5, which would leave you with 3a plus 2 over 36. Either of these answers is just fine. Okay, either of these is just fine. This would be more helpful if there was a number down here that I could cancel with the negative 5. Okay, we're going to look at one more example that involves some kind of more intricate factoring, and then we'll give you some problems to work on. Okay, so last example that's a little bit more complicated. So I have a minus 3 over a squared minus 2a minus a minus 4 over a squared minus 4. Here it looks like very clearly I have some factoring to do before I can find the common denominator. If I factor this first denominator, I get a times a minus 2. If I factor the second denominator, it's a difference of 2 squares, a minus 2, a plus 2. Now to find the least common denominator, I need to, in a sense, find all of the factors altogether. So my LCD for the whole fraction is going to have an a, and an a minus 2, and also an a plus 2. Notice that's everything that they have all together. They share an a minus 2. So here's what my denominator is going to be. A times a minus 2 times a plus 2. Now the question is, how do I change the numerators? Well, to go from here to here, I already have an a. I already have an a minus 2. What I don't have in this first fraction is an a plus 2. So to change the denominator to this, I multiply by a plus 2, which means that's what I need to multiply the numerator by. So this numerator is going to become a minus 3 times a plus 2. All right, here's my minus. Now, what do I need to multiply this fraction by? Well, it already has the a minus 2 and the a plus 2. It already has these pieces. What I need still is the a. So I need to multiply that numerator by a and the denominator by a. Now my fraction's ready to go. So once you're at this point, all really you need to do now is simplification. So let's go ahead and simplify. In the numerator here, I can go ahead and FOIL. A minus 3 times a plus 2. I get a squared. It's my first term. My outer term is 2a. My inner term is a minus 3a. My last term is a minus 6. All right? I get a minus a squared, and a plus 4a. All right? Let's combine like terms. So I've got an a squared and an a squared, so those are going to cancel. I've got a 2a, a minus 3a, so it's minus a plus 4a, so that's positive 3a. Think about that again. Plus 2a plus 4a, that's 6a minus 3a is positive 3a, and then a minus 6. My denominator we already figured out is a times a minus 2, a plus 2. All right? Last thing I want to look at is see, can I cancel it all? Well, I can factor again this numerator. 3a minus 6, that is a monomial factor of 3. So this can become 3 times a minus 2. Three times a minus 2 over a minus 2, a plus 2. These a minus 2's will cancel. So I'm left with, in the very end, is my final answer. 3 in the numerator, a times a plus 2 in the denominator. All right, so look back over this. We'll pause for a second, and then we'll work on some problems together.